Okay, guys, I have just a little bit of a assistance in making your calculations and understanding circular motion. In particular, we're talking today about uniform circular motion. That means, right, the uniform part is because the speed at every single point as something's moving around in a circle is constant. We can't say that it's a constant velocity because the direction is changing, but we can say that it is a constant speed because we are moving around this circle at a constant speed. Anytime you're moving around in a circle, in a circular shape, there will be acceleration that is directed towards the center of the circle. That is just to say there is a centripetal acceleration. There is not a particular special type of centripetal force. We're still going to be holding on to the fact that our net force is just equal to mass times acceleration. In this case, for uniform circular motion, that net force is equal to mass times the acceleration that is directed towards the center. It doesn't have a specific direction like up, down, left, right, because it's the direction of the acceleration is changing, but the nature of that direction is towards the center of the circle. And the equation that we use to describe that is that the centripetal acceleration is equal to v squared over r. That should make at least some conceptual sense where the faster you're moving, the larger of an acceleration you need to stay in that circular path. Similarly, if you have a very, very small radius, then you would need a very, very strong acceleration to keep you in there. This equation really by itself is the only unique thing for making calculations with circular motion. Really quickly, I'm going to go through an example question that really is going to cover, I think, all of the bases for what you need to be able to do to solve your homework questions. So here we have a record which is rotating at 20 RPM. This is one of the things that students find to be kind of challenging. 20 RPM, that means revolutions per minute. But what we can think of in order to help us with our speed is remember that, one revolution, right, is one distance around this circle. That's the time it takes for it to repeat. So we can think about one revolution as really just being related to the circumference, right? The time that it goes around the circle. So I can kind of say one revolution is equal to 2 pi times r. Another thing that we want to keep in mind is that when we use r in that equation, v squared over r, we're talking about the distance from our center of rotation. So even if this record is 25 centimeters wide, for this ladybug, it's going to be going around at 15 centimeters. And so one of the first things that I'm going to need to do is calculate, right? How do I calculate the speed that this ladybug is traveling as they're going around this circle? Well, that speed is going to be distance over time. So I want to calculate the distance that they're going to travel. And that distance, so if I say, all right, the speed is going to be the distance over the time, the distance traveled is going to be, well, the distance around this circle, so that'll be 2 times pi times 15 centimeters. But I'm also going to say, well, it goes around that distance 20 times in a time period of 1 minute, which is 60 seconds. In order to convert this to meters per second, I'm actually going to go back over here. And I'm going to say, instead of multiplying times 15 centimeters, I don't want centimeters per second. I'm going to calculate this in meters per second. So that'll be 0.15 meters. All right. So that's going to give me the speed at which I'm traveling. And that speed is going to be about, in this case, 0.31 meters per second. All right, now I have the speed, so I just need to calculate the centripetal acceleration. All right, the centripetal acceleration is going to be v squared over r. Sorry, I was interrupted just a minute. Anyway, we're taking the centripetal acceleration, calculating that as v squared over r, which is going to be the 0.31 squared divided by the radius, which is 0.15 meters, and that would be 0.65 meters per second squared. Now, if we're thinking about what's going on with this object, we know how they're moving, we know how it's moving, and we know the acceleration, right, towards the center. But in order to calculate something like friction, I have to kind of change my perspective. Instead of looking from the top down, where I'm really only seeing one force, and actually this would be a frictional force that's going to keep them in place. This is a force of friction here, because without friction to make them move in a circle, this thing would just continue to go off in a straight line like Newton's first law would dictate. Now that we've done most of the calculations, I'm actually going to take this and I'm going to get rid of this, and now we're going to actually look at this from a side view. So if I'm picturing this from a side view where I'm level now, looking, and I can see that there is a force of gravity that's down, a normal force that's up, and the center of the circle now would be towards this direction, and that would be, again, my frictional force. Well, here, now I have the ability to solve in the vertical and horizontal. I know force of gravity is equal to mg. And if I look in the vertical, I see Fn minus mg is equal to 0. So I know that my normal force is equal to mg. And I know that my frictional force is equal to my centripetal net force, my net force from my centripetal acceleration, that's mv squared over r. In this case, I would say, well, my frictional force is mu times the normal force, which I actually know is mass times acceleration due to gravity, and I can set that equal to my mv squared over r. Now, this is a common thing to see in a lot of different problems. Just because you don't know the mass doesn't mean that you can't solve, because a lot of times, because mass is a component of this gravitational force, when I solve and mass is in my acceleration net force equation, a lot of times I'm going to end up finding that mass is not actually that important. So in this case, I can actually see mu is equal to v squared over rg, or, you know, if I actually calculate this, v squared over r was that 0.65, g was there. So in the end here, I would end up calculating this as 0.065, and there is no unit for our coefficient of friction. So hopefully looking over this, you'll be able to work your way through the calculations. Make sure to draw everything out that you can, and email me if you have any questions.